I think it's time to get this thing started. So welcome everyone to another fantastic guest lecture for Xamarin University. We have Paul Betts today. Really excited to have Paul. Paul's absolutely fantastic. Paul used to work at GitHub, and he was a big C# guy over there. Pushed a lot of cool projects over there into C# and whatnot. And now he's over at Slack, and that's also super cool because we at Xamarin we recently switched over to Slack. First we were on IRC internally for a lot of our internal chat communication, and then we switched to GitHub, or I'm sorry, HipChat. And HipChat was okay, but we've upgraded to Slack recently, and it's way better. So it's pretty cool having someone come in and give a talk when they work at technologies that we use every day. So like I said, really excited to have Paul, and I can't wait to get him started. So take it away, Paul.
All right. Yeah, thanks for having me. So today we're going to be talking about the reactive extensions for .NET, and really today is going to be like kind of more of like an overview, like why this is cool kind of thing. Trying to teach this library in an hour is very difficult, and so we're gonna do our best. So it's definitely not going to be comprehensive. It's more going to be like here's why it's cool and why you should look into it more. All right, let's get started. So before I can talk about Rx and what it is, I get to talk about sequences. There's a few really cool things about sequences. So the thing we have to remember is that sequences are a list of things in some order that may or may not end. Right? Most enumerables in C# always end, but they don't have to. Right? Like you could make an enumerable that's like digits of pi, right? And then you just go on forever, and you keep calling like get next, and you keep getting items. And so this particular order isn't necessarily sorted order; it's just like an order, right? If I ask for the enumerable again, I'll get the same order out. And so in LINQ, one of the things that's really important is that sequences are lazy, right? They don't do anything until we look at them with for each. So here's my demonstration. All right, so I have enumerable.range 0 to a bajillion .select, and each select is thread sleep for 1,000 milliseconds. And so this line executes immediately, and we see the console write line, even though you'd think that it'd take forever. But it doesn't because nobody looked at this. It's lazy. This thread sleep won't execute until somebody for eaches through this list, right? So that's important to remember. So that's really cool because I can take that operator and add like, where more selects, I can return it, and then somebody else can add more selects to it. And they didn't do the operation more than once. They didn't waste time until somebody for eaches at the very end. So sequences are really cool because on top of them we can take those lists and build more interesting lists, and we can use these operators that we've got in LINQ to do that. We can use select, we can use where, aggregate, select many, and we can use operators to take dumb lists and turn them into more interesting lists. So that's really cool. That's really useful. Sequences are pretty cool. Sequences we can assign to variables, we can put them together, we can combine them, we can do operations on them, we can do all this cool stuff with sequences. But in C# we also have events, and events are not cool. Events show up everywhere in .NET, and not just with the event keyword, right? There's like 8 different ways to have events in C#. There's tasks. A task is an event, right? It's a thing that happens once. We have the begin-end pattern that used to be in .NET 2.0. We have callback methods. Callback methods are events, right? Because there's something happening and it's telling you about it. And we have C# events. And there are all these different kind of syntax, right? Like tasks, you use like continue with and begin end. You implement some interface, and callbacks, you implement a method. We can't treat them the same. We can't combine them together. More importantly, C# events are not first class. First class effectively means that you can assign it to a variable. So I can't take my button.clicked and assign it to a variable. The only thing I can do with an event is add a handler or remove a handler. I can't even events, if you look into them like internally, they're actually a very weird part of .NET. It's a very strange construction that you don't think about until you actually dig into the internals of it. Anyway, neither here nor there. But let's look back at our sequence. This seems like this talk about link and sequences seems unrelated, but let's see how it's maybe related. So sequences are a list of things in a particular order that may or may not end. It's like, well, that's kind of an event too, right? Let's look at this. So we have textbox.keyUp, right? And then we add a handler that says right line the character. And this is probably incorrect syntax, but whatever. And then we have HELLO. Well, that sounds a lot like a sequence too. It's just a sequence that hasn't happened yet. It's like a future sequence. So the point is that Reactive Extensions takes all the things you know about sequences in LINQ and applies them to events. So Rx is a library that creates a better event. So unlike LINQ, Reactive Extensions is not built into the framework. It's just a library. So you go on NuGet and the package name is rx-main, and you add to your project just like any other NuGet package. Rx is a library that creates a better event. So let's look at this if we wrote it in Rx. So instead of keyUp being an event, a .NET event, we're going to make it this type called iObservable. iObservable is our type that represents an event. And so the cool thing is we can take all these operators and bolt on stuff. So we can say, I'm not interested in just like key up. I want to key up and read 5 items one at a time. So we're going to keep like the last 5 things we saw, and we're going to move along that. We're going to move along that like timeline one at a time, but we're going to keep the last 5 items. And then we're going to select it just like we select in LINQ, and then join those last 5 characters into a string. And then we're going to say where if it's hello. And so we've taken this dumb event, key up, and turned it into a way better event, the user typed hello. And then we can take that event and we can either directly listen to it, or we can pass it to some other function. We can combine it with some other event. We can do really interesting stuff. So this would not be a joy to write if you did it with C# events. But with Rx, it's very easy. So Rx takes a lot of things that are very difficult in other paradigms, or really error-prone, or race conditioning, or difficult to test, and makes it really easy to write. So a lot of problems like I just don't know how to solve any other way. So cool. So iObservable is an event. So in Rx, events can do 3 things. Observables can produce values via a method called onNext. So it's going to give you an item, give you an item, give you an item. And then observables can complete. They can say, we have no more items. They can also complete with an error, like throw an exception. So this is really similar to IEnumerable, where IEnumerable, you get an enumerator, and that enumerator you can call getNext, and then it returns a false or true based on whether it has a next item. That's kind of your onCompleted, whether it's false or true. Or when you could call getNext, it could throw an exception. So instead of throwing, we have a callback called onError. And so once an observable terminates by onComplete or onError, you can never restart it again. And this sounds really limiting, but it's not, because you can actually do things like concatenate observables, or like join them together. or restart them. And so this actually isn't a big deal. So with this, no, I'm going ahead. With this abstraction, we can model pretty much any kind of event. So if we think about like a .NET event, that's pretty easy. We just have like on next forever, and it never on completes or on errors, right? Because like if I have event for key up, there's no time when they're going to stop typing. I guess if the computer like shuts off or like sets on fire or something. But until then, it's never going to complete. So most UI events as observables will never on completed or on error. You could also model things like a task, right? And so the way that you model a task is that it would do nothing. It would do nothing for a long time, and then suddenly, immediately on next and on complete because the task is finished. Or we could model like a callback in the same way, where it's on next maybe n times because callbacks are very flexible, and then on complete, right? Or on errors, like something bad happened. And so we can model any kind of .NET event using this abstraction, which is really cool. And this is one of the important things to get from the talk, is that observables don't do anything until you subscribe to them. So right here, we've got this code sample. This takes a long time. Select to calculate a bajillion digits of pi. Doesn't do anything. As soon as you call subscribe, that's what does the work. And right here's an example of this scheduler thing, right? Because I didn't move this to another thread, I didn't say that I wanted this to be on a background thread, this subscribe is gonna block the thread because it's doing this work in context. I could choose if I wanted to put that on a different thread and then it wouldn't block the main thread, but because I didn't, it will, which is cool because in a unit test runner, it means I can make all of my asynchronous calls synchronous. And so now they're super predictable, but in my app, they're not synchronous. They run in the background. So the important thing to know is that subscribe is like for each in link. Subscribe is the method that kicks off everything that actually does work. Just like for each in link is the thing that actually does work. So there are a few methods that are like sneaky subscribes or sneaky for eaches, like first and last. Generally, you can tell that they're going to evaluate the expression by if they don't return IEnumerable or IObservable. So first returns like a value, like int or string. So it has to evaluate the enumerable, right? And so IObservable has first and last two, and when you call them, they block because it has to wait for the first item and return you that value. So how can you create observables? You can create observables, canned observables from arrays. You can create them from a single value using that function return. So return will on next the value and then immediately on complete. If you create it from an array, it'll as soon as you subscribe, it'll run through the array on next, on next, on next, on next, on next, and then on complete when it finishes the array. So we can create observables from .NET events. We can create them from tasks. One way to create observables that's really useful, especially for bridging existing code, is called a subject. A subject, a lot of the names in RX are from like the academic computer science world, and so subjects is a very opaque name, in my opinion. A subject is just an observable you can control by hand. So it's something you can subscribe to, and you can create. It's an observable that you can also just manually call on next, and you on next anywhere in your code. So you're like on next, on completed, whatever. It's kind of like the list, like list of T is to IEnumerable. Subject is the list T of observable. It's just one you can control by hand. And so it's really useful for bridging code that doesn't use RX, right? I'm sure like a lot of the framework, well, none of the framework is built around RX. So you end up writing a lot of code that's really boring to bridge the gap between your framework code or your apps code to make it more RX friendly, which is cool because that code is really boring. So like it's very mechanical and like easy to write, and you can reuse it everywhere. So as I mentioned before, all roads lead to iObservable. We can convert all kinds of different kinds of events and tasks and whatever to observable, and then once we do that, we can manipulate them all with the same language, right? We're using the same operators. I can await either a task or a .NET event, and put them together and say whichever one happens first. I can do all kinds of really interesting things, and I can use all the same language instead of trying to operate them all differently. So you may be asking yourself, what about async await? I've heard that's super cool. Doesn't that? Why shouldn't I use that instead of this observable thing? Here's the good news, is that you can actually await iObservable just like you can await task. So iObservable is awaitable. In fact, you can actually await anything. Like if you write a method called getAwaiter, you can await like buttons. You could await a Boolean if you wanted to, as long as you created a method that would. It's actually not. A lot of people think you can only await task, which isn't true. So you can await iObservables, and we're going to see that in a code sample that is coming up soon. Tasks and observables are really easy to convert between each other. So I can say like some observable.toTask or some task.toObservable. So you may ask, like, how can I convert an observable to a task? Observables return, n things, and tasks only return one thing. When you convert an observable to a task, you get the last item. So it's as if you said like observable dot take last one dot subscribe. So this is important. We'll see. The star is a disclaimer. So when you await an observable, it's kind of like implicitly like converting it to a task. And so the point is that some code will be easier to understand using RX, and some code will be easier to understand using async await. And you can use both. You can combine them. You can use whatever makes the code easier to understand. I find that oftentimes my higher level code, my controlling operations, like the view controller kind of code, is more RX-y, and the lower level code that's actually doing some of the work is more async await-y. That's just my personal experience. Your mileage may vary, but you can use both, is the point. Here's the catch. This is the disclaimer. It is super easy to await an observable that never completes. And if you do it, you'll just never continue. Your async method will just like disappear into the ether. And in Visual Studio, you can see that in the tasks pane. You can see a task that is not completed. But yeah, you can await things that will never complete. So if I await key up never ends, right? We can always keep typing in our app. So if I await it, it will never end. And so this code will never get called. So, but the good news is I can always make an observable end early via a whole bunch of different means. So I can call, take, I can say take until, all these different ways to make an observable end early. So I'm going to say take one. So I want to wait till the next keystroke. And then when somebody hits the keyboard, then I'll see this message. So I've taken the best app ever, which I believe has been used several times in the Xamarin University courses, and changed it up a little bit. So one place that's really in your Xamarin apps, existing Xamarin apps, where RX can be really useful is in kind of like the data backend layer. And so let's have a look here. So what I've done is in references, I've added a package, RX main. And RX main is a package that'll pull in a bunch of other small packages here, like core interfaces, link. You don't have to worry about that. And so originally, this class has a web service, and it had this method called getSongs, and this is the original getSongs. And so it's a pretty classic, like, async await method, like, moves up a web client, calls download string task async, converts it to JSON. So that method's pretty cool. But on top of it, we'd like to add like a little bit more safety, right? So we want to make it so that we want to retry a couple times if something bad happens. And we want to make it so that if this website just like stalls for a way long time, then we want to give up on it. So here I've taken this method and renamed it to getSongs internal. It used to just be getSongs. And so I've created this new method, getSongs, that's going to do our awaiting, or our timeouts and retries. So one thing I've done is that I didn't talk about this in the talk because I wanted to keep it short. But we have this concept of cold versus hot observables. So events, when you listen to them, all the listeners are getting the same result. They're all getting the same key up, whatever. But if you think about like observable.return, if as soon as you created it, it emitted the value and completed, it'd be useless, right? Like nobody could ever subscribe to it because it immediately, as soon as you created it, end. So most observables are lazy, and so we call that a cold observable. Just like, so when you call subscribe, then it actually does the work. Unfortunately, getSongs internal is not lazy. As soon as I call this method, it's going to do the work. So I've got to make it lazy. And so I have this method called observable.defer. So it creates an observable that every time somebody subscribes, it calls this method, getSongs internal. And so that means I can subscribe more than once, and I'm going to make more than one web call, which is what I want. Because what I'm going to do is I'm going to call .timeout on it. What .timeout does is it'll wait for a certain amount of time, and if something doesn't come out, a value doesn't come out, then it's going to on error. So it's going to shut down the observable. And so this method do is like a select that just returns the original value. It's just a way to like put in the console write line. And retry is the cool one. So what retry does is it's going to subscribe to its parent. It's going to subscribe to this, and if it on errors, it's just going to subscribe again. So we're going to do that 4 times, and then if it keeps failing, then we're just going to give up. But the important thing is that retry is resubscribing to the source. So unless I use this defer, I just get the same result 4 times. So defer and retry are kind of like buddies. And so here I've said like, okay, if it really failed, like it really didn't work, then we're just going to return an empty list. We're going to replace the observable with this new observable that's just return. And if you remember, return is just return. It just returns a single value on completes. So let's have a look. All right, so let's get some songs. Reactive UI is a library that I wrote. So Rx is a library like Link. It has no domain. It just is like, it doesn't know anything about UI frameworks or anything. And so Reactive UI kind of bridges the world of UI frameworks using Xamarin.Forms, using all of the Xamarin products, using .NET, using WinRT. Please don't use WinRT for anything, ever. So we can see that the app works. It's super boring because my internet is not terrible. But here we can prove that it will actually, we can stop the app. And we can set this timer really, really low. My internet is not this good. Pow. Cool. So there we go. So we retried 4 times, and then we still didn't get a response because we set the timeout to be very, very low, and then we died. And because nobody caught that exception, we killed the app. Cool. So it looks like I actually am ending a little early. So that's all I've got. And so the cool thing about this, is that get songs, and normally when you write code around like timeouts and retries and stuff like that, or combining observables, or combining like asynchronous operations, you end up like mixing all the code together. Like you mix the notion of timeouts and retries into the code that handles fetching this file. And so timeout is really generic. Like I can write operators, I can write things, bolt-ons, asynchronous things that are generic instead of having to re-implement it every single time. So retry is generic, timeout is generic. I can add that to any method I want, and that's really cool. So the general idea of Reactive UI is that it takes one of the most interesting events in terms of UI development is a property change notification. So like when you have a view model, knowing when that properties on that view model change is really cool, and being able to take those changes and combine them together. So like if you imagine like a color picker dialog, right? It's got usually 4 properties on it. It's got red, green, blue, and then like final color. But final color isn't a property that you really set. It's like a property that's derived from the other ones. And this is super common in UI programming. Like you see, like once you start thinking in those terms, you see it everywhere. And so really final color should be like whenever red, green, and blue change, update final color. And so you can say stuff like that in Reactive UI. You can say like you can take properties and turn them into observables. So you can say like when any value of x dot red, and then now that's an observable you can subscribe to, and you can combine it together with other ones. So you can say like merge red, green, and blue, and then select it into a color object or a UI color in Cocoa, and then put that into a property called final color. And then that makes it so that you can't set it by hand. You can only set it via this derived property. And then the other thing it does is it takes commands, commanding like iCommand. In general, like things that are in Cocoa, you use the target action framework to do stuff like this, like things like buttons or menu items. The user wants to do a thing. So commands are really events too, right? Because there's somebody clicked on something or did something, and so we can turn those into observables too. And so our version of iCommand is built around background tasks. So the common task that's super common and no other framework really helps you at all with it is that like I invoke a command, I do a background operation, and then give you back the result on the UI thread. And so when you subscribe to a reactive command, which is the name of the type in Reactive UI, it will invoke that task on the background for you, and then the thing you get back is the results on the UI thread. And so that makes it really easy to connect to
Very cool.
applications. Yeah. Cool. Thank you so much for having me.